Hello students, welcome to Diksha Karnataka YouTube channel. In this video, I'm going to discuss COMEDK 2022 previous year paper. Okay, COMEDK 2022 paper. Okay, so the first 30 questions. Yeah, let's see. The question number 1. During the phenomenon of resonance, option A says the amplitude of the oscillation becomes large. Option B says the frequency of the oscillation becomes large. And option C says the time period of the oscillation becomes large. All of the above. During the phenomenon of resonance, the amplitude of the oscillation becomes large. Okay, not frequency, not time period. The amplitude of the frequency becomes large. So option A is the correct answer. Okay, yeah. Next one. If the earth were to spin faster, acceleration due to gravity at the poles. Okay, so this is the earth. Okay, here it is rotating with angular velocity omega. Okay, so now the angular velocity increases. Okay, now it is omega dash. So they are asking at the pole, what is the acceleration due to gravity? Here at the pole, the acceleration due to gravity remains same, right? Isn't it? At the equator or somewhere here or somewhere here or somewhere here, the acceleration due to gravity increases, right? Isn't it? Because of the spin. Here at the pole, acceleration due to gravity remains same. Okay, so option C is the correct answer. Okay, yeah. Next one, question number 3. Maximum amplitude of message signal in amplitude modulation is 20 centimeter. So amplitude modulation AM equal to 20 centimeter, that is 0.2 meter. If the amplitude of carrier wave is 40 centimeter, that is AC equal to 40 centimeter, which is equal to 0.4 meter. Then modulation index of the modulated wave is. So modulation index mu we need to find, right? Mu equal to modulation index is the ratio of the amplitude modulation to the amplitude of carrier wave. Okay, so here AM is 0.2 and AC is 0.4, which is equal to 0.5. So the correct option is B. Okay, yeah. Next one, question number 4. If heat engine is filled at the temperature 27 degrees Celsius, in Kelvin this will be 300, and heat of 100 kilocalorie. So we have to convert calorie to joule. So that is 100 into 10 to the power 3 into 4.2 joule. Taken from source at temperature 677 degrees Celsius, in Kelvin this will be 950. Work done is, okay, so here the work done W is equal to efficiency of the engine into Q1, that is heat given. Okay, so let us find efficiency of the engine. So efficiency of the engine, eta equal to 1 minus Q1 divided by Q2, and which is also equal to 1 minus T2 by T1, right? So 1 minus T2 by T1. So now here what is T2? Here the source temperature T1 is 950 Kelvin, right? Isn't it? And the heat given, sorry, and heat of 100 kilocalories is taken from the source, right? Isn't it? That is Q1. Okay, so now eta is equal to, here T2 is 300 Kelvin, right? So 1 minus 300 divided by 950, right? So now eta is equal to, now solve this, you will get 13 divided by 19. Okay, so eta is 13 divided by 19. So now work done W is equal to eta into Q1, right? So now W is equal to 13 divided by 19 into Q1 is 100 into 10 to the power 3 into 4.2 joule. Okay, so now solve this, you will get work done is equal to 0.28 into 10 to the power 6 joule. Okay, 0.28 into 10 to the power 6 joule. So the correct option is A. Okay, yeah. Next one, question number 5. During alpha decay, atomic mass of parent nuclei is. So during alpha decay, the here atomic mass of parent nuclei decreases by 4 units. Okay, 4 units. So the correct option is C. Okay, yeah. Question number 6. A point object is placed on the optic axis of a convex lens of focal length f at a distance of 2f to the left of it. Okay, let us draw the diagram. Here, convex lens, to the left of the convex lens on the optic axis, a point object is placed, right? Point object is placed. The distance between the convex lens and the point object is 2f. This is the object distance, right? Okay. The diameter of the lens is d. Okay, so the diameter of the lens is d. So now this will be d by 2, right? D by 2. D by 2. And eye is placed at a distance of 3f to the right of the lens. Okay, here eye is placed. Okay, eye is placed at a distance of 3f to the left, right of the lens, and a distance h below the optic axis. Okay, distance h below the optic axis. The maximum value of the h to see the image. Okay, we need to find the maximum value of the h to see the image, right? Okay, here object placed at 2f distance from the convex lens, right? Isn't it? So image will form at 2f distance from the convex lens. Okay, where will be the image form? To the right of the convex lens, right? So here image will form at 2f distance. Image will form, right? Now this distance will be f. The total is 3f, right? Okay, so this is 3f, sorry, f. Okay, so we need to find h, right? Here this is a and b. Okay, so this point is o and this is m, and this will be 2f, right? Isn't it? Or you can call it as r. Okay, now look at the triangle OM and, okay, this is C. Okay, OM and C, the triangle OM and C is similar to CAB, right? So now apply similar triangle. Here H divided by D by 2 is equal to F divided by 2F, F divided by 2F. So now H equal to D by 4. So this is the maximum height. Okay, maximum value of H to see the image. So the correct option is D. Okay, yeah. Next question, question number 7. For collector emitter transistor amplifier, the audio signal voltage across the collector resistance of 4 ohm is 5 volt if the current amplification factor, that is beta of the transistor is 100. Beta of the transistor is 100 and base resistance is 2 kilo ohm. Here RB is 2 kilo ohm. Okay, RB is 2 kilo ohm. 2 kilo ohm. Then input signal voltage. Okay, we need to find input signal voltage, right? So now here the voltage gain, right? Sorry, voltage amplification AV is equal to output signal voltage by input signal voltage, right? So which is also equal to beta times output resistance by input resistance, right? So we need to find V input, right? Isn't it? So V input is equal to V output into R input divided by beta into R output, right? So V input equal to V output into R input divided by beta into R output. Here what is R input? R input is base resistance, right? And R output is collector resistance, isn't it? So this has to be 4 kilo ohm. Okay, 4 kilo ohm, not 4 ohm. Understood? So now V input is equal to V output. Here the V output is 5 volt, right? So 5 into R input is 2 kilo ohm, that is 2 into 10 to the power 3, okay, divided by here the current amplification factor 100 into R output is here 4 kilo ohm, right? 4 kilo ohm, 4 kilo ohm. So kilo ohm will get cancelled, right? So now 2 2s are 4, right? Then 5 divided by 200. So V input is equal to 5 divided by 200. So V input is equal to 25 milliampere. Okay, so the correct option is B. Next question, question number 8. From the following PV diagram, an ideal gas undergoing a change of state from A to B. Here ideal gas undergoing change of state from A to B. Here from this point to this point. 4 different processes, 1, 2, 3, 4, as shown in the figure, may lead to the same change of state. Option A says work done is maximum in case 1. Yeah, correct, right? Here the work done is maximum. Why? The work done in PV graph is equal to area under PV graph, right? PV graph curve, isn't it? So option A is correct. Option B says change in internal energy is same in all the 4 cases. Yeah, that is also correct, right? Change in internal energy does not depend on the path taken, isn't it? So in all 4 states, all 4 cases, the change in internal energy is same. Yeah, correct. Okay. If you take option A or option B, you will get the full marks. Okay. Change in internal energy is same in 4 and 3 cases, but not in 1 and 2. Wrong. Work done is minimum in case 2. In case 2, work done is not minimum. In case 3, work done is minimum. Okay. Yeah. So the correct options are A and B. Next question, question number 9. A copper and a steel wire of same diameter are connected end to end. Here, this is the copper wire and steel wire. Okay, steel wire. Steel wire connected to end. Okay, a deforming force F1 is on applied to the wire, which causes an elongation of 1 centimeter. The 2 wires will have, option A says the same stress. Yeah, the 2 wires will have same stress, right? Same stress, right? What is stress? Stress is force per unit area, right? Or force by area, force per area. So here the area is same, right? Here the F1 is applied, or here the F1 is applied. Because of the F1, the applied F1, what happens? There will be an elongation, right? Isn't it? So the diameter of the copper wire and steel wire is same, right? So therefore the stress will be same on both both wires. Okay, but the strain is different. Strain is not same. Okay, strain is not same. Strain is different. Understood? Stress is same, strain is different. Why? What is strain? Strain is change in length over original length, right? Isn't it? So here the Young's modulus of copper and steel is different, right? So therefore the strain is different, isn't it? So option A says the same stress, correct. Option B says different stress, correct. Option C says the same strain, wrong. Sorry, option B is wrong, right? Isn't it? Option B is wrong. Okay, different stress is wrong. Okay, option D says same strain, correct. Option A and D are correct answers. Okay, not A, B. A and D are correct answers. Next question, question number 10. If kinetic energy of the body is increased by 300%, then percentage change in the momentum will be. Okay, so initial kinetic energy of the body is K. Now new kinetic energy is K dash is equal to K initial kinetic energy plus it is increased by 300%, right? So 300 divided by 100 into K. So 100 will get cancelled. New kinetic energy will be 4K, right? New kinetic energy is 4K. Okay, we need to find change percentage change in momentum, right? So what is the relationship between momentum and kinetic energy? Kinetic energy K equal to P square divided by 2m. So P equal to root 2mk, right? P equal to root 2mk. Okay, so now here the percentage change in momentum will be percentage change in momentum, right? Is equal to change in momentum divided by original momentum into 100%, right? So delta P, percentage change in delta P or change in momentum is change in momentum, that is final minus initial, right? So final will be root of 2m into 4k minus initial is root of 2mk divided by again initial root of 2mk, which is into 100%, right? So now root of 2mk will get cancelled. So now root of 4 is 2. So 2 minus 1, right? 2 minus 1 is 1, isn't it? So 1 divided by 1 is 1 only. So percentage change in momentum is equal to 100%. So the correct option is A. Okay. Yeah. Next one, question number 11. Which of the following diagram represents the variation of electric field with distance r from the center of uniformly charged non-conducting sphere of radius r? Okay, so this is the non-conducting sphere of radius r. Okay, so this is point P. Okay, the distance between point P and the center of the non-conducting sphere of radius r is small r. This is another point, okay, x. Here the distance is r, right? Isn't it? R equal to r. So this is another point y. Okay, so this distance is r dash. Okay, r only. R is lesser than capital R. So now what is the electric field at point P? Electric field at point P, right? That is R is greater than R, which is equal to K into the charge on this non-conducting sphere is Q. So KQ divided by R square. Okay, so here the electric field is directly proportional to 1 by R square. So now electric field on the surface of the non-conducting sphere, so this will be KQ divided by R square. Okay, so now inside the non-conducting sphere, right? So inside the non-conducting sphere, what is the electric field? The electric field will be KQ into R divided by R cube, right? Here the electric field is directly proportional to R. Okay, so if you draw the graph of E versus R, so from center to the surface of the conductor, what happens? Electric field increases linearly, okay, because E is directly proportional to R. So on the surface of the conductor, the electric field is KQ by R square, that is the maximum. Then it decreases, right, inversely, square of the inverse, right, like this. So this is E versus R graph. This is R equal to R. Here E is directly proportional to 1 by R square. Here E is directly proportional to R. Okay, so the correct graph is C. Okay, yeah. Next one, question number 12. A DC ammeter and a hot wire ammeter are connected to a circuit in series. Okay, here hot wire ammeter is ammeter which allows AC current. Okay, when a direct current is passed through circuit, the DC ammeter shows 6 ampere. When AC current flows through the circuit, it shows 8 ampere. What is the average reading in DC ammeter and the AC ammeter if DC and AC current flows simultaneously through the circuit? Okay, so now DC and AC current flows simultaneously through the circuit, right? Isn't it? So let us find, so we have to apply principle of superposition theorem, right? Isn't it? So now let us find the average current, average DC current passing through the ammeter, okay, and then average AC current passing through the ammeter. Okay, so now average DC current passing through the ammeter, that is IRMS, right, which is equal to 6 ampere only, right, 6 ampere. Now average AC current passing through the ammeter, right, isn't it? So now here we need to find IRMS. So now IRMS, here IRMS is 8 ampere, right? IRMS 1, here IRMS 2. IRMS 2 is 8 ampere, isn't it? And we can write it as I naught divided by root 2 is equal to 8 ampere, isn't it? So now we need to find AC reading. So AC reading will be, AC reading is equal to root of square of the DC current, right? So that will be 36, right? Plus square of the AC current, that is IRMS 2, right? So that will be 64. So AC reading will be 10 ampere, right? Isn't it? 10 ampere. So here the first one is 6 ampere and then 10 ampere. So the correct option is A. Okay, DC is 6 ampere, AC current is 10 ampere. Understood? So when DC and AC current flows simultaneously through the circuit, what happens? DC current shows 6 ampere and AC current shows 10 ampere. Okay, next one, question number 13. A bullet of mass m hits a mass capital M and gets embedded in it. If the block rises to a height h as a result of this collision, the velocity of the bullet before the collision is, okay, so velocity of the bullet before the collision we need to find, isn't it? So now this is the block, okay, now bullet is moving with initial velocity v, okay, now both will collide, okay, and bullet will attach to this block. Because of that, block will rise, okay, block will rise. Here the bullet is there. So it moves with velocity v, okay, it moves with velocity v. Here what is the total mass? Total mass will be m plus m, okay. So here the block's mass is capital M, right? Okay, so now apply conservation of momentum theorem. So what is the conservation of momentum theorem? Initial momentum equal to final momentum, right? So initial momentum is equal to final momentum, isn't it? So what is the initial momentum? Initial momentum is mass, momentum of the bullet plus momentum of the block. Momentum of the block is 0, momentum of the bullet is, so this is v, right? Okay, this is v dash. So momentum of the bullet is m into v and momentum of the block is 0, which is equal to final momentum. Final momentum is m plus m into v dash. Okay, so now v dash is equal to m into v divided by m plus m. So now apply conservation of energy theorem, okay, conservation of energy theorem. Okay, now you would say why we are applying conservation of energy theorem? Because it's an inelastic collision, right, isn't it? But our system is block plus bullet, right, isn't it? So in our system there is no external force acting on, right, isn't it? So we can apply the conservation of energy theorem. Apply conservation of energy theorem here. Here the loss of kinetic energy is equal to gain in potential energy, right? When it moves up, what happens? It gains kinetic energy, isn't it? The height is h, right? So loss of potential energy is half m, sorry, loss of kinetic energy is half m plus m into v dash squared, okay. So here our system is block plus bullet, okay. So that's why we are applying conservation of energy theorem. So loss of kinetic energy is equal to gain in kinetic energy. So that will be m plus m into g into h, okay, m plus m into g into h. So now V dash is mv divided by m plus m, right? So now half into, anyway m plus m will get cancelled, right? M plus m will get cancelled. So V dash squared, okay, here V dash is equal to root of 2gh, okay? V dash equal to root of 2gh. V dash is m into V divided by m plus m, which is equal to root of 2gh, right? So now V is equal to here root of 2gh into m plus m by mv, right? Sorry, m plus m divided by small m. Here 1 plus capital M divided by small m. So this is the speed of the bullet before the collision. So the correct option will be B. Okay, yeah. Next one, question number 14. A particle of mass m is moving in a horizontal circle of radius r under a centripetal force given by minus k by r square, where k is the constant. Then the total energy of the particle is minus k divided by 2r. Okay, let us find the potential energy, kinetic energy and total energy. Here, this is the particle and particle is moving in a circular path. The force, centripetal force on the particle is minus k by r square, right? Centripetal force is mv square by r. mv square by r is equal to minus k divided by r square, right? So r will get cancelled, isn't it? So kinetic energy is half mv square. mv square is minus k by r, right? So which is equal to half into minus k by r. So kinetic energy is minus k divided by 2r, okay? Minus k divided by 2r. So anyway, kinetic energy is wrong, right? Whatever they have given, it is wrong. So let us find potential energy. Here the potential energy U equal to integration of f dot dr, right? So potential energy U equal to integration of f dot dr, right? So now potential energy U equal to, here the potential energy U equal to F is minus k divided by r square, right? Sorry, this will be minus f dot dr. So minus k divided by r square into minus, that will be plus dr, right? So now the potential energy U is equal to, here the potential energy U equal to, so this will be minus k by r, right? Minus k divided by r. So potential energy is wrong, right? Okay, so now what is the total energy, right? We need to find the total energy. So now the total energy is equal to kinetic energy. Kinetic energy is minus k by 2r, okay? And the potential energy is minus k by r, right? So kinetic energy is, so this has to be plus, okay? So this has to be plus, so this will be plus k by 2r minus k divided by r. So this will be minus k by 2r, okay? Sorry, here there's a sign mistake, okay? So this has to be plus k by r, okay? So this is plus k by r square, okay? I'm taking the magnitude of the centripetal force, okay? Plus k by r. So now the total energy is minus k by 2r. Why? Because kinetic energy is k by 2r and potential energy is minus k by r, okay? So now the correct option is A, okay? Yeah. Next one, question number 15. The height at which the acceleration due to gravity becomes g by 16. Here, what is the acceleration due to gravity at height h above the surface of the earth? So g dash is equal to gm divided by r plus h whole square, where g is acceleration due to gravity on the surface of the earth in terms of r, if r is the radius of the earth. Okay, we need to find the height at which acceleration due to gravity becomes g by 16 in terms of r. So now multiply and divided by r square. Okay, so G dash is equal to Gm divided by R square into R divided by R plus H whole square. G dash is G by 16, right? So G divided by 16 is equal to Gm by R square is acceleration due to gravity on the surface of the earth into R divided by R plus H whole square. So now take square root on both sides. Here G will get cancelled. Okay. So now R plus H divided by R equal to 4. So now R plus H equal to 4R. So now H equal to 3R. H equal to 3R. So the correct option is B. Okay. The correct option is B. Next question, question number 16. Which of the following series spectrum of hydrogen atom lies in ultraviolet region? Okay, Lyman series lies in ultraviolet region. Okay, so then P fund bracket, here P fund bracket and Paschen series, all these three are lies in infrared region. Okay, infrared region. So this lies in ultraviolet region. Ultraviolet region. Okay, yeah. So correct option is D. Next question, question number 17. Speed of electromagnetic wave in medium having relative permittivity epsilon r and relative permeability mu r is. Okay, what is the speed of magnetic wave in a medium, right? Okay, here we know that speed of light in vacuum is c, which is equal to 1 divided by mu naught root of mu naught into epsilon naught, right? Isn't it? So speed of light in medium, which has relative permittivity and relative permeability, so that will be V is equal to c divided by root of mu r into epsilon r. Okay, how I got this formula? You remember the refractive index. Refractive index n is equal to c divided by V, right? Refractive n equal to c by V, and we also know that refractive index n equal to root of epsilon divided by epsilon naught and mu divided by mu naught. From this I got this formula. Okay, so the correct option is B. Next one, question number 18. The wavelength of the second line of Balmer series is 486.4 nanometer. Okay, in Balmer series second line, right? Okay, second line, right? Isn't it? So when we will get second line in Balmer series, when electron makes transition from n equal to 4 to n equal to 2. Okay, Ni, here this is Nf. What is the wavelength of the first line of Lyman series? So when we will get first line in Lyman series, when electron makes transition from n equal to 2 to n equal to 1. Okay, then we will get the first line of Lyman series. Okay, so we know that 1 by lambda is equal to Rydberg constant R into 1 divided by Nf square minus 1 divided by Ni square. So in Balmer series, right? So in Balmer series, lambda b, 1 by lambda b is equal to R into here 1 by Nf squared, right? Nf is 2. So 1 by 4 minus Ni squared is 1 by 16. Okay. So now 1 divided by lambda b is equal to, take 1 by 4 as common. So 1 minus 1 by 4, 1 minus 1 by 4 is 3 by 4. So 3 by 4 into 1 by 4 is 3 divided by 16, right? So 3 divided by 16 times RH, right? Or R, okay? So next in Lyman series, right? Again use this formula. 1 divided by lambda L is equal to here 1 by Nf squared, right? So that is 1 divided by here 1 divided by this has to be Ni. Okay, this will be Nf. Nf is 1. So 1 divided by 1 square minus 1 divided by 2 squared, that is 4. Okay, Nf is 1, Ni is 2. Electron makes transition from 2 to 1, right? Okay, so now 1 minus 1 by 4 is 3 by 4. So 1 by lambda L is equal to 3 divided by 4. Okay, so we need to find lambda L, right? So now divide 1 by lambda b to 1 by lambda L. So we will get lambda L divided by, so R term is there. Okay, so lambda L divided by lambda b is equal to 1 by lambda b is 3 by 16R whole divided by 3 by 4R. Okay, so now 3 will get cancelled, so this will be 4 and R will get cancelled. So now lambda L is equal to lambda b divided by 4. Lambda b is 486.4 nanometer divided by 4. Okay, so lambda L is equal to 121.6 nanometer. So the correct option is B. Okay, yeah. Next one, question number 19. A bat emitting an ultrasonic wave of frequency 4.5 into 10 to the power 4 hertz at speed of 6 meter per second between two parallel walls. Okay, so let us draw the diagram. Okay, so two walls. Now bat, it is emitting frequency 4.5 into 10 to the power 4 hertz. The source of the, speed of the source is 6 meter per second. The two frequencies heard by the bat. Okay, what are the two frequencies? So first one, here the bat is emitting the frequency, right? So what happens? The sound wave will collide with this wall and it will come back. Okay, so this is the first frequency heard by the bat. Okay, so now the second one is this sound wave. Here another sound wave will travel back and hit this wall and then again come back, right? Now another sound wave, the frequency of the sound wave is F2. Okay, so these two are the two frequencies heard by the bat. So now for the first case, here the efferent frequency F1 is equal to F into, here this will be V plus U divided by V minus U, right? So this is the formula we need to use. So now F1 is equal to F is 4.5 into 10 to the power 4, right? Isn't it? So here V is velocity of the light in air, U is velocity of the source. Velocity of the light in air is 330 plus 6 divided by 330 minus 6. Okay, into 10 to the power 6. So now here F1 is equal to, so now 330 plus 6 is 336, right? 4.5 into 336 divided by 324, right? 336 divided by 324. So now F1 is equal to 4.67, right? 4.67 into, so 10 to the power 4 is there, right? 4.67 into 10 to the power 4 hertz, 10 to the power 4 hertz. Okay, so now for second case, that is for this case, the formula will be F2 is equal to F into V minus U divided by V plus U. Okay, so now apply all the values, you will get F2 equal to F is 4.5 into 10 to the power 4, right? V is 330, U is 6, right? Substitute all the values, you will get 4.34 into 10 to the power 4 hertz. Okay, so the correct option is A. Understood? Yeah. Next one, question number 20. A disk of moment of inertia 4 kg per meter square, 4 kg meter square, revolving with 16 radian per second is placed on the another disk of moment of inertia 8 kg meter square revolving 4 radian per second. The angular frequency of the composite disk. Okay, so this is the first disk. Okay, it is revolving with 16 radian per second. Okay, so now another disk, okay, is placed on the first disk. Okay, so the another disk rotating with 4 radian per second angular speed. Okay, so now the angular uh, velocity changes, right? Angular velocity changes. So now here angular velocity, second disk and first disk. Angular velocity is omega dash. Okay, or omega. Angular velocity is omega. Okay, so we need to find the value of omega, right? Apply conservation of angular momentum theorem, right? So why we are applying conservation of angular momentum theorem? Because there is no external torque acting on our system, right? Isn't it? So what is the conservation of angular momentum theorem? Initial angular momentum equal to final angular momentum. What is the initial angular momentum? Moment of inertia of the first disk, I1, into angular velocity of the first disk plus moment of inertia of the second disk into angular velocity of the second disk, which is equal to, so now second disk is placed on the first disk, right? So now the total moment of inertia I1 plus I2 into common angular velocity omega. So now omega is equal to I1 omega 1 plus I2 omega 2 divided by I1 plus I2. Okay, so now omega is equal to I1 is 4, right? I1 is 4 and omega 1 is 16, I2 is 8, omega 2 is 4 divided by 8 plus 4, that is 12. Okay, so now omega is equal to here 16 into 4 is 64 plus 32 divided by 12. So now omega is equal to 64 plus 30 is 94, 94 plus 2 is 96, right? 96 divided by 12. Okay, so now 4 3s are 12, right? And then 4 2s are, isn't it? 4 2s are 8 and then 4 4s are okay, so this will be 24, so then 8, so omega equal to 8 radian per second. So the correct option is C. Okay, yeah. Next one, question number 21. An electric current I enters and leaves a uniform circular wire of radius r through diametrically opposite points. A charged particle q moves along the axis of the circular wire, passes through its center with speed v. The magnetic force on the particle when it passes through the center has magnitude. Okay, so this is the wire. Okay, here the current enters and leaves diametrically opposite points. Okay, these two are diametrically opposite points, right? So this is the axis of the circular ring, okay, or circular coil. Okay, here the charge q moves along this axis of the circular coil. So we need to find the force acting on the charge when the charge enters the center of this circular wire, right? Okay, so now apply the right hand thumb rule, right? So this is how the current flows, right? I and I. Okay, so the magnetic field at the center due to upper half will be towards left, right, at its center. Now magnetic field at the center of the circular wire due to the lower half current is towards right, isn't it? So now force acting on the charge is q into v into b sine theta. Theta is angle between v and b, that is 0 degree, right? Isn't it? 0 degree, sine 0 degree is 0. So force acting on the charge is 0. So the correct option is D. Okay, yeah. Next one, question number 22. A television frequencies are of the order of 100 megahertz, while the radio frequencies are of the order of 1 million hertz. Okay. Using these typical frequencies, the ratio of the EMF generated in a loop antenna by a television wave to that generated by radio wave, if both have equal electric field intensity. Okay, both have equal electric field intensity, right? Okay, so now here what is induced EMF? Induced EMF E is equal to d phi by dt, right? Induced EMF E equal to d phi by dt, right? So phi is B into A, right? Phi is B into A. So now E is equal to A into dB by dt. E into A into dB by dt, right? So what is the magnetic field wave? Here the magnetic field wave B equal to B naught into sine of B naught into sine of so there are two waves, right, isn't it? So B1 equal to B naught into sine of 2 pi F1 plus phi, okay, and then B2 equal to B naught into sine of 2 pi F2 plus phi. So now differentiate B1 and B2 with respect to t, okay. So now E1 divided by E2 is equal to differentiate B1 with respect to t, we will get B naught into 2 pi F1, okay, B naught into 2 pi F1 into cos of 2 pi F1 plus phi, okay, whole divided by B naught into 2 pi F2 cos of 2 pi F2 plus phi, okay. So anyway, cos 2 pi F1 cos 2 pi F1 plus phi, cos 2 pi F2 plus phi, both will get cancelled. Here B naught will get cancelled, 2 pi will get cancelled. So E1 divided by E2 is equal to here 100 megahertz, right? 100 megahertz divided by 1 megahertz, okay, 1 megahertz. So megahertz will get cancelled. So this will be 100, okay. Answer will be 100. So the correct option is C. Understood? Yeah. Next one, question number 23. A particle is performing simple harmonic motion. Equation of its motion is x equal to pi sine of 40 minus pi by 6. X being the displacement from the mean position, velocity in meter per second of the particle at the instant when its displacement is 3 meter will be, okay. So this is 3 meter, displacement is 3 meter will be, okay. So we need to find the velocity of the particle when the displacement is 3 meter, okay. So here the displacement is 3 meter, 3 equal to 5 into sine of 40 minus pi by 6, right? Okay, so now sine of 4 into t minus pi by 6 is equal to 3 by 5, okay. So now sine of 4 into t minus pi by 6, 4 into t minus pi by 6 is equal to sine inverse of 3 by 5. Sine inverse of 3 by 5 is 37 degree. So 40 minus pi by 6 is 37 degree. Okay. So now differentiate x with respect to t. Okay. So dx by dt is equal to 5 into 4 into cos of 4 into t minus pi by 6. 4 into t minus pi by 6 is 37 degree. Okay. So now velocity of the particle when x equal to 3 meter will be 20 into cos of 37 degree, right? So what is the cos of 37 degree? 4 by 5. 4 divided by 5. So this will be 4, which is equal to 16 meter per second. So the correct option is D. Okay, yeah. Question number 24. A raft of density 600 kg per meter cube and mass 120 kg floats in water. Okay, so the density of the raft is given, right? And mass of the raft is also given. It is floats in water, right? How much weight can be put on the raft to make just sink? Okay, so this is the raft. Okay, initially it was floating. Okay, so now we have to put some mass m so that this raft will just sink, right? Like this. Like this. Okay, so we need to find the value of m. Now here the raft is completely sinked, right? Completely sunk, right? Isn't it? So let us find the volume of the raft, right? We have to apply the floating condition, right? In that case, what is the volume of the water displaced in the second condition? Volume of the water displaced is equal to volume of the raft which is inside the surface of the water, right? So that is the whole volume of the raft, right? So density and mass of the raft is given. So volume is equal to mass divided by density. Mass divided by density. Okay, so V equal to 0.2 meter cube. Okay, V is equal to 0.2 meter cube. This is the volume of the raft, right? So now apply floating condition, right? So M and raft both are floating, right? So now the gravitational force on the system M plus raft is equal to buoyant force. The buoyant force is density of the water into volume of the water displaced, that is equal to volume of the raft into G. So now G will get cancelled, right? Now we need to find M. So M equal to rho W into V minus 120. So now M equal to rho W is density of the water, that is 1000 kg per meter cube, into V is 0.2 meter cube minus 120. Okay, 0.2 into 1000 is 200, 200 minus 120 is 80. So which is equal to 80 kg. So the correct option is D. Okay, yeah. Next one, question number 25. The displacement x of a particle in a straight line motion is given by x equal to 1 minus t square. The correct representation of the motion is, okay, we need to find correct representation of the motion, that is x versus t graph, right? Isn't it? Okay, so here let us differentiate x with respect to t. Okay, dx divided by dt is equal to differentiation of 1 is 0, differentiation of t is minus 1. So differentiation of minus t will be minus 1, differentiation of minus t square will be minus 2t. Okay, so now v equal to minus 1 minus 2t. We know that the first equation of motion v equal to u plus at, right? So compare this equation, these two equation. Okay, compare these two equation, then we will get x versus t graph, right? X versus t graph, right? So anyway, acceleration is negative, right? And v is not linear, right? Isn't it? In x versus t graph, it is not linear. The graph or the curve will be not linear, okay? Isn't it? Because acceleration is there, right? And it starts from 1, right? Initial velocity is also there, right? Sorry, not initial velocity. Here at t equal to 0, x equal to 1, at t equal to 0. So anyway, option A is wrong. Okay, option A is wrong, and option C is also wrong, right? Option A is wrong, option C is also wrong. So the correct option between A and D, right? Okay, so now at x equal to 0, sorry, at t equal to 0, x equal to 1, right? So then it decreases, right? So it continuously decreases, isn't it? Like this. It is not increasing, okay? It won't increase, it continuously decreases. So the correct option will be B. Next one, question number 26. Galvanometer having a resistance of 4 ohm shunted by a wire of resistance 2 ohm. Okay, let us draw the diagram. Okay. Here I, okay, the resistance of the galvanometer is 4 ohm, okay, and the shunt wire has resistance 2 ohm, okay. If the total current is 1.5 ampere, here I equal to 1.5 ampere, the current passing through, okay, the current passing through G, okay, the current passing through G or I, we need to find, okay, current passing through shunt resistance or G. Okay, let's see. Here, the current passing through the G is Ig, okay. Here, I minus Ig, okay. So now apply KVL, okay, apply KVL here. So now Ig into G, okay, Ig into G equal to I minus Ig into S, okay. I is given, right, I is given, so we need to find Ig, G and S is also given, right. Okay, so now Ig into G plus S is equal to Is. So now Ig is equal to Is divided by G plus S. What is I? 1.5 ampere, not angstrom, okay, 1.5 ampere. So 1.5 into, here this is Ig, okay, 1.5 into S is 4 ohm, right, sorry, S is 2 ohm, okay, S is 2 ohm, not 4 ohm, 2 divided by G is 4 and S is 2, 4 plus 2, 6. So now Ig is equal to 1.5 into 2 is 3, so 3 divided by 6, that is 0.5, so 0.5 ampere. So the question has to be here, the complete question has to be the current passing through the G is, okay, so which is equal to 0.5 ampere. So the correct option is D, okay. Yeah, next one, question number 27. In Young's double slit experiment, the two slits are separated by 0.2 millimeter, that is small d equal to 0.2 millimeter. They are 1 meter from the screen. The wavelength of the light is used 500 nanometer. The distance between the 6th maxima and 10th minima on the screen. So what is the condition for maxima? The condition for maxima is n lambda d divided by small d, okay. So this is capital D and this is lambda, and for nth minima the condition will be here 2n minus 1 into lambda d divided by 2d, okay. So what is the distance between 10th minima and 6th maxima, right? So now delta x is equal to 10th minima, right, minus 6th maxima, which is equal to, now n equal to 10, right? So 10 into 2 is 20 minus 1 is 19, isn't it? So 19 divided by 2, I will take lambda d divided by d as common. So now n equal to 6, right, for maxima. So minus 6 into lambda d divided by d. So now delta x is equal to 7 by 2 into 7 by 2 into, here lambda is 500 nanometer, so 500 into 10 to the power minus 9 into d is 1 meter divided by small d is 2 into 10 to the power minus 4 meter, okay. So now delta x, right, delta x is equal to, here solve this, okay, solve this, you will get 8.75 millimeter, 8.75 millimeter. So the correct option is D, okay. 8 millimeter is close to 8.75, right? So the correct option is D. Question number 28. Okay, before that there is a small correction, okay. So here the resistance is 100 ohm, okay, it is given. Yeah, a LCR circuit connected to an AC source of 220 volt and 50 hertz shown in the figure. If the reading of the 3 volt meters V1, V2, V3 are 65 volt, 415 volt and 204 volt respectively, the value of inductance and capacitance will be. Okay, so value of inductance and capacitance is given, right? Yeah, sorry, inductance and capacitance we need to find. So let us find the current flowing through the circuit, that is IRMS. IRMS is equal to VR, that is potential difference across the resistance, okay, resistor VR divided by the resistance R. So now IRMS, which is equal to I, equal to 65 divided by 100, okay, 65 divided by 100. So I equal to 0.65 ampere. So let us find XL and XC, then only we can find VL, L and C. So now VL is equal to, here VL is equal to I into XL, right? And VC is equal to I into XC. Okay. So now XL is equal to VL divided by I. XC is equal to VC divided by I. Okay. So now XL is 2 pi FL and XC is 1 divided by 2 pi FC. So 2 pi FL, right? 2 pi F into L is equal to VL divided by I. 2 pi FC, sorry, 1 divided by 2 pi FC is equal to VC divided by I. Right? So now L, here I will write here L equal to VL divided by 2 pi F into I, and C is equal to I divided by 2 pi F into VC. Okay, so now substitute the values. Okay, here L equal to, substitute the values, F is 50 hertz, okay, and VL is given here, this is VL, sorry, this is VC, okay, and this is VL, okay, VL, VC is given, I we know the value 0.65 ampere, F is 50 hertz, okay. So now solve this, here you will get L equal to 1 Henry, okay, L equal to 1 Henry, and C equal to I is here 0.65, right, divided by 2 into pi into 50 into VC. VC is 415. So now solve this, you will get 5 microfarad. C and L values are 5 microfarad and 1 Henry. So the correct option is here B. Okay, correct option is B. Okay, next question, question number 29. A regular hexagon of side M, which is a wire of length 24 M, is coiled on that hexagon. If the current in the hexagon is I, then the magnetic moment, okay, so magnetic moment M is equal to number of coils N into I into A. N into I into A. So let us find N, the number of coils or number of turns. Number of turns, N into how many sides are there? 6, right? In hexagon there are 6 sides. So 6M is equal to 24M. The total length is 24M. M will get cancelled. N equal to 4. Okay. And A is area of the hexagon. What is the area of the hexagon? 3 into root 3 divided by 2 times square of the side of the hexagon, so that is M square. Okay, so now magnetic moment M equal to N is 4 into I into 3 into root of 3 M squared divided by 2. Okay, so now this will be 2, so 6, right? 3 into 2 is 6, so 6 into root 3 into I M squared. So the correct option is A. Next question and the last question. Which of the following gate give the similar input as the output of the circuit diagram shown in the figure? Okay, let us find the output of the diagram, then we can compare, right? Isn't it? So here the output is A dash, right? Here this will be A dash and this is B dash, right? So now this is NOR gate, right? So what is the output of the NOR gate? The output of the NOR gate will be here Y dash, okay? So Y dash will be equal to, so what is the value of Y dash, right? So Y dash will be equal to A bar plus B bar whole bar, right? So this is A bar, okay, not just A dash, A bar, okay? So this is A bar and B bar. So now output is Y dash. Y dash is equal to A bar plus B bar whole bar, right? So we know that A plus B whole bar is A dot B, A bar plus B bar. Sorry, A plus B whole bar is A bar dot B bar, right? So here A bar plus B bar whole bar. So that will be A bar bar plus B. Here Y dash will be equal to A bar bar dot B bar bar. Okay, so Y dash is equal to A dot B. Y dash is equal to A dot B. So this will be, the output will be A dot B whole bar. Okay, output will be A dot B whole bar. Understood? So this is the output. So now here this output, right? So this will be Y equal to A dot B whole bar dot A dot B. Okay, so now solve this, you will get Y equal to A dot B. So this is AND gate, output of the AND gate, right? So the correct option is A. Okay, the correct option is A. Thank you so much for watching this video. Okay, if you love this video, please like and share, and if you want to watch more such videos, please subscribe. Thank you.